forgot to turn the projector on. Oh, did something to my hip yesterday. So I'll have the tests back on Thursday. I don't have them today. Actually, last week was kind of busy, and then I got a cold, and I just didn't feel up to it yesterday, so I decided not to do it. But did you? Okay, so we're talking about central tendency, and we took the data that was on my screen and we put it into, I forget which kind of spreadsheet, whether it's Excel or the other one. So I'm going to do the same thing today, just with a different set of data, just to demonstrate how you do it. And again, there'll be a video for the project, so just try to absorb the general concepts here, and the specifics you can watch the video later to get the details. I haven't said that yet. I haven't assigned it yet, so I don't. Okay, so what I'm going to do is, yep. Here's the question. Yeah. Yeah, I haven't assigned it yet, so don't worry about it yet. Okay, let me, what I'm going to do is I'm going to open up, we'll do it in the Google Docs version. So remember, what you have to do is you have to log into your Gmail account, and then you yeah, no, I ignore it because that's a lot from YouTube, from all my YouTube things I've created. So you'll go to Sheets. So that's the Google app. Oh, Sheets, yeah. The first time I used Sheets to get gas, it must have had water in the gas or something, and my car started sputtering and had to get some dry gas. And after that, I didn't go to Sheets for a long time. Yeah, yeah, and I would say I'm not buying any of that sheety gas. That was my. Okay, let me, so I have some data somewhere here. Oh, here it is. Okay, so I'm just going to copy this data that I have in an Excel spreadsheet. I'm going to copy it to the other spreadsheet, so you don't need to worry about this right now. Okay, so what I have is 200 data points. Yeah, I don't want to enter those. Yeah, I don't want to add all this stuff together. So I'm just zooming in so you can see the numbers a little better. So we're going to figure out what the mean is using the formula, and to calculate the median. That you can use the formula, but we'll show you how you actually do it manually. And we'll create a histogram, because you're going to have to do that again. So typically what I do is, if I have a listing of data in a column, I'll go to the bottom of the column and I'll do the the statistical calculation. So if I go all the way down to the bottom of my data, which I don't need to go that far, so it's right here. So there's the last data point. So the mean, you add the numbers together and you divide by the total, the number of data points. So I'm going to do that manually, and then I'm going to then I'm going to use the built-in function. So to add things together, if you remember the formula, it was the summation of x. So the equation, and this is the same for both Excel as in Google Docs spreadsheet, is the word sum. And you always put an equal sign. Anytime you're using a formula, you put an equal sign first. If I just put sum, it would think, without the equal sign, it would think it's text. But by putting the equal sign, it's going to say, oh, it's a calculation. And I'm going to go from cell A1, and then if you put a colon, that tells you that it's from that cell to the next cell, everything in between. So I'm going to say A200. Now I could have just highlighted these with my cursor. Yeah, it's like, yeah, it's everything in between. If you just put a comma, if you put a comma, A1, comma, A200, then it would just be averaging those two numbers. But if you do a colon, it does everything between the two. And apparently that's not the right answer. Oh, that is the right answer. Okay. So I forgot to do the rest of my calculation. So that's the sum. If you add all those numbers together, you get 19,565. But the average is divided by the number of data points. So I put divide by 200, and I get 97.8. So that's how you calculate a mean manually. Now, if you want to use the built-in formula, you just type in mean, and you do A1 colon A200, and you get the same number. Didn't like that. What isn't it like? Maybe mean is not. Huh. Okay, let's go back here. Usually, maybe it is average. Let's see. What it will do is it will pop up functions that starts with the letter M. So let me do that again. So equals M. I don't see mean in there, so maybe they do use average. How about average? There we go. Okay, so it's actually average. Yeah, there we go. So it's actually average, not mean. So I'm going to use average, and I'm going to go A1 colon A200, and I should get 97.825, which I did. Okay, so that's also the mean. They're the same. You know, one was done manually by adding the numbers up and dividing by the total number of data points, but that's an easy thing for a spreadsheet to do automatically. Okay, so the next thing is the median. Now, to do the median, you always have to order the data. So I'm going to highlight all the data cells. So we'll go highlight 200 data cells. And then if you go to data, sort, and so what we're going to do is you can sort the spreadsheet, but I don't want to do that. I just want to sort the range. That means sort the part that I highlighted. So I click OK, and it's going to sort it in numerical order from smallest to largest. If I did this, it would be from largest to smallest. Okay, so now it's all sorted. My lowest value in the 200 data points is 27.3, and my highest value is 160.9. So the median is the middle number in that list of numbers. So what I always do is I always create a column just listing which number it is. This is the first number in the listing. This is the second number. And then I copy this sequence, meaning I'm going by ones. I copy that down for the entire set of data. So I'll get 1 through 200. And then it'll make it easy to find where the center is. Okay, so that's all those just for reference, so I can find the middle part easier. Now I could use these cell numbers, but if those cell numbers are not starting at 0 or starting at 1, if you had it somewhere else on the page, sometimes it's hard to figure out. So it's just a lot easier to locally define the numbers according to their order numerically. So the median is the middle. Now there's two cases. There's one if you have an even number of numbers and or an odd number. So let's look at a simple case, and then we'll come back and we'll do it for this case. So let's go back to Blackboard. Let me go back to my spreadsheet. So, yeah. Okay. So let's say I have a list of numbers. I'm just going to list 6 numbers. 1, 2, 3, 4, 5, 6. I'm going to list 5 numbers. 1, 2, 3, 4, 5. So if I have 6 total numbers, which is an even number, these are the 2 middle numbers. So what I'm going to do, I'm going to average those 2. So the median in this case is 3.5. So it's the 3rd number and the 4th number. So if I take this is the total number of entries. So if I take the total number of data points I have and divide by 2, that'll give me 3. So what I'm going to do is I'm going to take this number, I'm going to take the 3rd number and the 4th number. So in my case, I have 200 numbers. So if I divide 200 by 2, I'll get 100. So the 2 numbers that I'm going to average together are the 100th number and the 101st number. I might have to get a drink of water in a second. Well, because that's not exactly the middle. Now, if you do this case, if you have 5 numbers, if you take 5 divided by 2, you get 2.5. So typically what you do in this case is you round it up to the next higher number. So when you have an odd number of data points, you divide your total number of data points by 2, and then you round up to the next higher number. If you have an even number of data points, you divide the number by 2, which is going to give you a whole number, and you use that number plus the next one. Okay? So that means if I go back to my spreadsheet and use that rule, in this case I have 200 data points. So what that means is the 100th and the 101st numbers should average together should be the median. So I'm looking in column B. So in this case I have, so my median is going to equal this number plus this number, and I need to divide by 2, so I'll do that in a second. So that's the sum of the 2. I forgot to put a parentheses here, so if I put a parentheses around it and divide by 2, that's going to be the median. So it's the average of the 100th and the 101st number. Now there's a built-in calculation function for that as well called the median. So you'd say median. So median, and in this case you don't put in the 100th and 101st number, you put in the range of numbers that your data are associated with. So I do the same range as I did before, which is from A1 to A200. So it says what is the median, and they don't have to be, the nice thing about the spreadsheet thing is they don't have to be in order for them to figure it out. They'll figure it out themselves. They have some internal calculation which will order them and then choose the 2 middle and average them together. So if I know anything what I'm talking about, this is always dangerous to say that, I should get the same number as I did doing it manually, and I do. So that's a lot easier than, I don't have to order them to use this calculation. I had to order them here when I did it manually so that I could take take 200 data points divided by 2 will give me the 100th and the 101st data point are the two middle numbers. Now what I'm going to do is I'm going to take one of the data points, I'm going to delete it, just to show you what when you have an odd number of data points. So I'm going to delete that, and actually let me delete this whole row. So let's cut that. So cut, okay. Control X. Actually, I want to delete, edit. Okay, I did that. Oh well, I'll fix it just a second. I'll do the brute force way. What I'm going to do is I'm going to take my original data here and I'm going to order it again. So there's going to be one less data point. That's just to get rid of that space. So sort by range. Okay, so now it's sorted. I'm going to do this again, and I'm going to renumber these. So if I highlight these two and I do this again, it'll renumber them to 199 because I have one less data point. Okay. Oh, let's try again. Okay, so, all right. Actually, I don't have to do that. It's already done. Okay, so I'm going to delete that. So there's only 199 data points. These two calculations don't match anymore because this one, I'd have to change this to 199. And this one, I'd have to change to 199. And they still don't match, so why is that? Okay, let's think about this. Oh, because I got to divide by 199. Okay, so they're matching again. Now, in the case of an odd number of data points, what we do is we take the 199 and we divide by 2, which gives us 99.5, and we round up to the next whole number, which is 100. So the median should be the 100th data point in this list. So instead of averaging these two numbers, the median is just going to be equal to 95.7. It's the 100th data point in the list. And you can see that this calculation here, if I put 200 to 199, it gives the same number. So that's the two cases. If you have an odd number of data points, divide the number of data points by 2, round up. That is the number you look for in the list of numbers when they are sequentially sorted. If it's an even number, you take the number of data points divided by 2. That number, the one that's divisible by 2, you take that plus the next data point, you average them together, and that gives you the median. Okay. The last thing we're going to do here is a histogram. So to do a histogram, we're going to have to figure out how we're going to break this up into classes. So if we look at the data, we go from 27 to 100 and where did it go here? Keep overshooting it here. The high number was 161. Okay, so let's go back to here and just figure out how we're going to break this up. And let me share this with you guys. Okay, so it was 27 to 160 something, 61 maybe. I think it was about right. So that's my range of numbers. I want to break this up into classes that are fixed width that are between 5 and 12. So if I take the difference of these two, so I'll get 134. So if I did it into 10 classes, they would be 13 units wide. Or I could think about if I did Or if I did them 10 units wide, there'd be 13 classes. That's too big. So probably the better thing to do is 10 is not going to work out. You'd end up with 134 divided by 10. That would mean I'd have 13 classes, which is more than 12, too many. So I would go to the next case, which would be, but then if I go to 20, well, that might not be so bad. Let's do 20. Let's do 20. So let's go from 20 to 40, 40 to 60, 60 to 80, 80 to 100, 120 to, well, 100 to 120, 120 to 140, 140 to 160, 160 to 180. So I have 8 classes. So that's good. So that's the classes that I have come up with manually to break the data up so that I have all the data points included. Each class is the same width. The number of classes was between 5 and 12. So now we'll go back to the spreadsheet and use that information to start doing the, where is it here? So you have to manually put in your class numbers here. So I'm going to go 40, 60, 80, 100, 120, 140, 160, 180. So what that's going to do, let me just go back up here. So what that's going to do is there's going to be a class which is going to be the numbers that are less than 40, 40 or less. And if I look at my data, I should have two which are 40 or less. The next one will be between 60 and 40. Now, 60 and not, so it's going to be greater than 40 and less than or equal to 60. And then the next one will be greater than 60 but less than or equal to 80. So we don't have any overlap because of the not equals to thing. It's going to be greater than but not equal to 40. So I don't know how many in there, it's going to be a smaller number, but to make sure it works out right, we should get 2 when we do this class. And you say, well, that goes to 0, but yeah, but this really only goes down to 20 because the smallest data point is 27, so it is the same width by default, but technically it's less than 40. And I'll show you, you'll see this on the video, but I'm just going to show you how this works. If you go to add-ons, and you can go to get add-ons. And they have a whole bunch of different add-ons depending upon what you're looking at doing. So there's probably some new ones that I don't know about. But you can see there's all kinds of math stuff, of course, because spreadsheet, Sudoku sheets, SurveyMonkey, Doctopus. Oh, you saw it, or you? Oh, where was it? Doctopus. Oh, Doctopus. Yeah, let's look at it. An octopus for docs. Teacher-built tools for scaffolding, managing, organizing, accessing student projects in Google Drive. So you can actually search. So if I search for histogram, so I want something to do histogram. Oh, you see there's Flubberoo, there's GMath for sheets, there's Excel Minor. I don't know. Google's. This is the one I use. So what you end up doing is you can choose. It says manage because I already have it, but if you want it, you can just click on it and it'll upload it to your spreadsheet. So if you have a special application, you might be able to find something that's already been done. So I have that in my. If you look at add-ons, I've got the Excel Minor Analysis Tool Pack. So we start that, and then we look for the one that we're interested in. And the only two that we're going to do is descriptive statistics and histogram. Excuse me. So I need to tell what range the data is in. I'm just going to enter it because it's going to be A1 through A199. The bin range is going to be D1 through D8. So I'm looking at this column. This is column D, and I have my first number in D1, and I know there's 180 below, so it's D8. My output range I'm going to put in E1, which is right here. So you actually can click on that cell and then go to here, and it'll automatically put it in. That's the other way of entering it. And I'm going to create a chart output. So I got everything I want. I've got the output, which is the frequency distribution, and I've got the chart output, which is the histogram. And I say OK. And I guess it's done. So now here's my output. So I've got two data points that are 40 or less, which is what I expected. I've got 10 in the next bin, and so forth. And I go down and I see that I've got one that's 180 or less, or actually, yeah, it's between 160 and 180, and I've got none that are more than 180. So I did a good job. Applaud for myself, and there should be a graph somewhere here. There it is. So there's the corresponding graph that's over here. Now, what I'm going to do is I'm going to put this on a separate page. So let me just move this in view. So if you click on this little upper right-hand corner, I can move the sheet to its own, the graph to its own sheet. That way I can see it better. So that's my histogram. That's my frequency distribution. And notice that the chart does have labels. But if I go back here and manually put in more descriptive, so if I go 20 to 40 and then push enter, if you push F2, that lets you put you in the edit mode. So I'm being more explicit about the labels. So that's 60 to 80. Next one is 80 to 100. The next one is 100 to 120. 120 to 140. So sometimes you have to go back and make some slight changes. It doesn't do everything automatically for you. And I can, if I delete this, it'll go off the graph. So I'm going to delete that because we don't need it. So if we go back and look at the chart now, you can see that the data, the classes are better defined. So here's from 20 to 40. Here's greater than 40 and less than 60, and so forth and so on. And you can see it has the most entries in this class in the middle, and the average was 80 something. So it's not surprising. This data actually is generated. It's actually an example of the kind of data that you'll use for your project. Yes. Yeah. So the project will have, everybody will get their own data. So you'll have to do, there's no copying somebody else's spreadsheet. Yes. I'll email you the data. I'll email you the data. So I will send you, the way I do this project is I actually create a random normal distribution, and I make different ones for each person, and I send it out so that everybody has to do their own calculations, so they can't just copy somebody else's project. Anyway, so this is a histogram. The median and the mean are within this class, which is, like I said, for a normal distribution is expected. Okay, so let's go back to just talk a few. There's a so we've talked about mean, talked about median. I'm just going to talk about this. I'm not going to test you on it. You might have some homework problems, but I'm not going to test you on it. So this is an example of a stem and leaf diagram. And remember how that worked was these numbers represent the first first two digits, and this represents the last digit. So this would be 97, 102, 104, 105, 107, 109. So what this is doing is it's using a stem and leaf diagram to actually show you a histogram. If you look at these numbers, the number of entries here, it's proportional to the, so if you rotate it 90 degrees, you'd have a histogram. And the height of the histogram would be the length of the rows. The other thing you can do, so that's, again, you'd look at it and say, well, it looks like the middle of this data is going to be, somewhere in this particular, between 115 and 119. So again, it's kind of a qualitative way of looking at it. You could probably do the median if you counted all the number, how many numbers do I have here, and then just count halfway up, and you could get the median. So, but 99% of the time, you're going to do what I did. You're going to use a spreadsheet to do it. So there's the homework for this section. That'll be due next Tuesday. Oh, like baseball data? Football data? If you can get enough data points, yeah. I mean, I don't want you to just, but yeah, there's a lot of data out there. If you can get something that has at least 200 data values, which sport do you like the best? Football. So let's see, what could you use for football that might have at least 200 data points? You could have like passing efficiency for quarterbacks over the last 10 years or something like that. That would be probably enough data points. Yeah. Yeah, hopefully you can find it. I mean, you search for football statistics. Let's just try that and see if we can find anything. I'm curious. So let's look. So I'm going to go to Google and football statistics. Let's see what data base Excel. Let's see what we got. View which one? Middle left up here? Oh. Okay, yeah. So let's, typically you can, see that's in a table. What we want is, they've got it in kind of a spreadsheet, but we'd like to be able to download it to our computer. Just thinking of how you might do that. Yeah, you can change the columns. What I'd like to be able to do is download the data instead of that's why I said I wanted Excel stuff. Let's see. Let's go down. Where can I get raw data? Let's see what this guy says. What's that? Oh well. I'm sure there's some places you get Excel files with data in it. Yeah, if you're determined to do it. Yeah. So if you can find something and bring it to me, I'll let you do that. Okay, back to the next section. Yeah, you can tell where we have different interests. When I was thinking about what would I do, what would be a good data set, and I thought of global warming, like temperatures or something, carbon dioxide. The scientist in me, Eli, wants to check out sports scores, or sports stuff. Okay, so the next section is on measures of dispersion. And there's one main measure of dispersion, which is standard deviation. So we'll show you how you calculate it. There is another one that's simpler, which is just the range. So the range for any set of data is just the greatest value in the set minus the least value in the set. So we actually used that just a second ago. I listed the smallest number, the greatest number. That was to figure out how many classes, but you could also use that. And you actually take the number. What is the difference between the two? You subtract the least number from the greatest number. So it was like 134 maybe on that last problem. So that's kind of the simplest way of doing it. The second way is calculating the standard deviation. And basically what the standard deviation is, it's looking at how the numbers are distributed away from the mean of the mean is the central tendency. So how far are the data points away from the central point? And we're not interested in whether it's negative, we don't care which side it's on. We're just looking for the distance between the center point and individual data points. So to make sure you get the distance, you don't just subtract one number from the other. You subtract one number from the other, the individual data points minus the mean value, and then you square it. But then ultimately we take the square root, which makes it so it's always positive. Yeah. So what you do is you take the individual data points. So you take the individual data values and you subtract the mean. So you'll get one number, one difference number for each data point. The ones that are above the mean will be positive numbers, and the ones that are less than the mean will be negative numbers. You square those numbers. So we square the differences, the deviation basically, and then you add all those squared numbers together. That's the summation. Then you divide by that. You divide by that sum of the squareds by the number of data points minus 1, and then you take the square root of the whole thing, and that gives you the standard deviation. But it's pretty much a measure of how far away from the mean you are. It doesn't matter whether you're less than the mean or greater than the mean. The important thing is the distance that we're talking about. So we'll go through an example. You'll see how it works. So the first step is you have to calculate the mean of the numbers. The second step is you find the deviations from the mean. So the first step is to calculate x bar. Then you calculate this difference, the deviations. Then you square those numbers so they become positive. The fourth step is you add up all those deviations squared. And then you divide by n minus 1. N's the number of data points. And then you take the square root. Okay, yeah, Eli's got to leave. Okay, so let's just do an example and go through the steps. So let's calculate manually. Well, we're going to calculate manually, and then we'll use the spreadsheet. So we have two sets of data. We have 7 data points here and 7 data points there. So if we looked at the range of the first set of data points, the range would be 11 minus 2, which is 9. And the range here would be 7 minus 5, which is 2. So this has a range of 9, this has a range of 2. So from the range, we would say this one has more dispersion, meaning that they both have the same mean, as you'll find out if you do the calculation. But this one, the values are further away from the mean than they are here. So we would expect this to have a higher standard deviation than the lower one. Let's just do we'll do the calculation by hand on a small set of data, and then we'll use the spreadsheet to do a larger set of data. Okay, so the first question is, what are the means of the two sets of data? Well, the mean is just the mean of the, we'll call this set A, we'll call this set B. So the mean of set A data is just equal to 2 plus 5 plus 7 plus 4 plus 7 plus 6 plus 11 divided by 7 data points. So that's 7 plus 7 is 14. 14 plus 4 is 18. 18 plus 7 is 25. 31, 41, 42. So 42 is the numerator. So 42 divided by 7 is 6. So the mean of data set A is 6. If we do the same thing for data set B, we'll have 5 plus 6 plus 7 plus 7 plus 6 plus 6 plus 5 divided by 7. So that's 11, 18, 25, 31, 37, 42. So they add up to the same number of data points. So the mean for these two sets of data is the same. It's 6. So from a central tendency standpoint, there's no difference between the data, but obviously there's a difference. So to calculate the standard deviation, it's best to make up a table. So let's do that. So we need a table, and let's see how many columns am I going to need. I'm going to need 1 for the data, 2 for the show, 3 no. We're going to need, let's see, I need a header row, 7 data points. I probably need 9, but I'm going to just go with 8 because that's as big as they'll let me do. And so I need the data. I need one for the deviation from the mean. I need to square it. But I can add all those things up. I think I only need 3, but I'm going to do 4 just to be on the safe side. If I don't need it, I won't need it. Okay, so here's my table. So this is my data. This is my deviation. This is my deviation squared. And I don't think I need this, so we'll leave that blank. So my data is going to be 2, 5, 7, 4, 7, 6, 11. Now the deviation is going, and the average I'll put down here, the average or the mean is 6. So the deviation is x minus x bar. So x is what's in this column, x bar is what's down there. So it's basically 2 minus 6, which is negative 4. So 2 is 4 less than the mean, so it's negative 4. So I'm going to do a few of these for using showing it completely, but once we get started, then so 5 is 1 less than that. So 5 minus 6 is negative 1. 7 minus 6 is 1. So the rest of them are going to be negative. I did that wrong. So 4 is 2 less than 6. This is 1 more. This is the same, and this is plus 5. So these are my deviations. And if I add all my deviations together, I should get 0. So negative 4 minus 1 is negative 5. Plus 1 is negative 4. Minus 2 is negative 6. Plus 1 is negative 5. Plus 5 is 0. So the deviations always add up to 0 relative to the mean. The next thing is I square the deviation. So I take the number in the second column and I square them. So I'll get -4 squared, which is +16. Here I'll get -1 squared, which is +1. And I'll get 1 squared, which is +1. And then I can just do the rest. So this is -2 squared is 4, 1 squared is 1, 0 squared is 0, 5 squared is 25. And then I add these together down underneath. So the summation, the sigma means summation. So I add these all together, 18, 22, 23, 33, 43, 48. So if you add all the deviations together, you get 48. So where we are on this whole thing is we have calculated the mean, we found the deviations, which was column 2, we squared each deviation, which was column 3, we summed the squares of the deviations, which is what I did below, right there. So that's the sums of the squares of the deviations. So the actual standard deviation, S is going to be equal to the square root of the sum of the deviation squared divided by n minus 1. So I've already calculated the numerator from this table. So the numerator is 48. And I divide by n, which is the number of data points. So I have 7 data points, and I subtract 1. And then I plug that in. So it's going to be basically the square root of 8. 48 divided by 6, which is 8. Take the square root of that, and I get 2.83. So that's the standard deviation. So what significance does, if I had a smaller standard deviation, that just means that the spread of the data is less. So when I do the standard deviation calculation for this data, I should get a smaller number. So relatively speaking, you just compare one to the other and say, it's bigger number, more dispersion, smaller number, smaller dispersion. We'll find out later that the standard deviation of each, well, if you look at the ratio of the deviation to the standard deviation, that's a special term, and certain percentage of most data is between plus or minus 1 standard deviation. So in this case, 1 standard deviation is 2.83. So most of these values should be within plus or minus approximately 3. And you can see that if we look at the deviations, most of them are between plus or minus 3. So how we have 7 data points, so 5 out of 7 are within plus or minus, rounding that off to a 3. This one, this one, this one, this one. There are 2 that are greater than 1 times the standard deviation. So there's some rules about that. If you have something more than 3 standard deviations away from the mean, so 3 standard deviations would be 3 times that, which would be approximately 8.5. If you were more than 8.5 away, the data point is very unusual. They're not usually that far away from the mean. So there are lots of things you can use standard deviations for. Right now we're just going to compare them. So I'm going to do the second set of data, and we're going to do the same calculation with that data. So I'll make up another, I will only make it 3 columns wide since I didn't end up using that 3rd column. So again, we have our data column. We have our deviation column. And we have our deviation squared column. So our other set of data was 5, 6, 7, 7. 5, 6, 7, 7, 6, 6, 5. Again, we've already calculated the mean is equal to 6, same as the previous one. So our deviations are going to be calculated the same way. So you take 5 minus 6, which is negative 1. Here you take 6 minus 6, which is 0. So now that I'm going to do the rest of them, just looking at them. So these two are 1 more than the mean. This one's the same as the mean. This one's the same as the mean. This one is 1 less than the mean. So you can see my deviations are definitely less. And if I square them, I'll get 1. So here I'm taking negative 1 squared. Let me write that again. So I'm taking negative 1 squared, which is positive 1. Here I take 0 squared, which is 0. So I can just look at these and square them now. 1 squared is 1, 1 squared is 1, 0, 0. Negative 1 squared is 1. So now I add them all together. And instead of getting 48, I only get 5. So the standard deviation in this case, same formula, this number is the numerator. And you have 7 minus 1 in the denominator. And so if we do the standard, we'll take 5 divided by 6, raise that to the 0.5 power. And so our standard deviation is 0.91, which compares with our 2.8683. So, so obviously this has less dispersion, and you can look at the numbers and see that. But you know, this is because it's a simple set of data. So again, if you can do something in a table, you can do it in a spreadsheet much easier. So I'm going to do the same. I'm just going to do this quickly for right now just to show you that you can do it in a spreadsheet. But you'll have to do this for your larger set of data. So let me switch over. So back to the data table. Actually, what we'll do is you can create a new sheet. There's a sheet for, it says sheet 1, one for the chart. I'm just going to create a new sheet, which is sheet 2. And so this is the data, this is the deviation, this is the deviation squared. And I'll enter my data. So 2574, 2574, 7611, 7611. Okay. So what I would do is I would calculate my average. In this case, I'm going to highlight the cells instead of using the colon, but you could do either way. And then you use the right parenthesis. So it says average A2 colon A8. And you should get 6, which I do. So that's my mean. I'll write that in there, mean. Now my deviation is going to be my data value minus my mean. And I have to change this to dollar signs. If you push F4, it'll change it automatically to dollar signs. What that does is it means that the denominator, or the second term, is the same in all these calculations. I'm always subtracting the same mean. So I get -4, which is what I got before, and then I can just copy that formula down, and I get all the deviations. And if I add the deviations together, I get 0. And then I would square the deviations. So I'd say equals, I'd click on this cell, I'd use the little hat, and then a 2, that's for squaring it, and I should get 16, which I do. And again, once you've done the formula, you can copy that formula down, and you get all the deviations together. And then we would add those together. So you put equals sum, which is the adding stuff together. Put a right parenthesis. I get 48, which is exactly what I got before. And then my standard deviation, I can say it's equal to the square root of this number, the sum of the squares of the deviations, divided by 7 number of data points minus 1, and I get 2.8284, which is the one I got. So it's all the same thing. It's just doing it in a spreadsheet. And you can see that the only thing that would be different in doing this calculation for 7 data points and for 200 data points is you would just have to copy the formula down further. But otherwise, you don't have to, there's not that much more work to do. Whereas if you had to do it by hand, it would be a lot more. And of course, so this is a standard deviation. There's a built-in function. So let me just show you what that is. It's equals STD, yes, sexually transmitted diseases, EV. And all you have to do again is put in the range of the cells where the data is. So you don't need all this extra stuff. So I'd go A2 colon A8. Those are the cells. And if I did that right, I should get exactly the same number, which I do. 2.8284. Okay. So this is something that you'll do for your project. But again, the video explaining how to do it will show you how to do it again. So you'll see it again. If I go back to this, just to show you how easy it is to do, or how much, I'm just going to do this and show you. I could probably do it in about a minute. So let's copy my data over here. So there's my 200 data points. So I'm actually going to do the mean up here. So that would be equals average, and it's going to be E2 through E1 200. So I get 97.688. Okay. This column, if I did the deviation, all I'd have to do is take this number and subtract that number. And I get negative 70.3. And then I could copy that down all the way to the bottom. Copying is easy. Yep, went too far. Okay, make sure you don't go too fast. So I'm watching the run numbers, so I know when to slow down, so don't overshoot it too much here. Okay, so there's the deviations. And then I could do the deviation squared, so I just say that squared. So those are the deviations. I copy that formula. Whoops. I copy that formula all the way down. Okay, and then I add them together. So it's G2 through G200. So that's the sum of the deviation squared, and then my final answer would be equal to the square root of this divided by 199, which is 200 minus 1. Actually, there's only 199 data points, so it'd be 998. So I get 23.51. And there's a the built-in function is standard deviation. And so I would do that based on the data. So that's E2 through E200. And if I did this all correctly, I should get the same answer, which I do. So you can see I don't know how long that took me, but it was probably less than 2 minutes. So, and actually this took me 5 seconds. So the built-in function obviously is the way you would go in practicality, but I am going to have you do the calculation just so you see what's involved. It all involves finding how far each number is away from the mean, and then squaring it to make it positive, and then basically taking the square root to get it back into units that are relating to the deviations and not to the deviation squared. So that's kind of the whole concept there. So we have the range, we have the standard deviation. The coefficient of variation is kind of how the deviation, standard deviation, is related to the actual magnitude of the number. So, for example, let's just use an example. You know, if you had some data points that were like 1, 2, 3, 2, 1. Okay, so those are 5 different numbers. The mean is obviously going to be, well, I don't know what it's going to be. Let's see what it is. It's 9 divided by 5. So it's, you know, the mean is going to be 9/5. Add these numbers together, divide by 5. But if I had like 101, 102, 103, 102, 101, I still have the same differences between the numbers, you know. And if I look at the standard deviation of these two calculations, I'm going to get the same number because the deviations are going to be the same relative to the mean, and so all the squares are going to be the same. So these two sets of data will have the same standard deviation, but relative to the size of the actual value, the standard deviation here would be much smaller relative to the value. So you can't just use the standard deviation blindly. You can use it comparing two sets of data that have the same magnitude. There you don't have to worry about what they mean in that sense. You just know bigger is more dispersion, and smaller is less dispersion. But if you're comparing standard deviations between two types of data, which is kind of, you know, not recommended anyway, but if you did, then you want to look at it, what is the size of the standard deviation relative to the actual magnitude of the quantity. So that's what the coefficient of variation is. You just take the standard deviation and you divide by the mean. So again, in this case, the mean would be about 102. The mean here is around 2. So if you but if they have both the same standard deviation, this one's going to have a much lower coefficient of variation than this set of data is. So again, the coefficient of variation is just standard deviation divided by the mean, multiplied by 100 to get it into a percent. This is this coefficient of variation for a set of sample data, which is what we normally deal with. If you have a population, meaning everybody or every possible instance of something, then you would use, instead of using S for standard deviation, you use sigma. This is the population or the sample standard deviation. This is the population standard deviation. This is the sample mean. This is the population mean. We don't really need to worry about those. If you took inferential statistics, you would, you know, that would be important. We're just dealing with samples at this point. Okay, so we already did that. We need to do another example. So there you go. That was that section. So you'll have, basically, the homework will be to take a set of data and calculate the standard deviation the long way using a table of some sort. So we've done a few examples here. So I guess that's due next Tuesday as well. So we're actually at a position where we could probably do about 95% of the project. There's just one small little bit that we have left to do. So what we know how to do so far is we know how to create a frequency distribution. Oh, also, yeah, this reminds me. I'm going to try to get a computer lab for next Thursday. I'll email you if I decide to do that. I'll email you tomorrow. So check your email tomorrow afternoon. And for you guys who usually don't come to class, I'll still do it online, but it would be much more useful for you guys if you were to come into class. For you guys who are normally here anyway, it doesn't make any difference. We'll meet in here, and then we'll go to the class that hopefully I can reserve to use the computers. And what we'll do is we'll go through an example similar to what will be on the for the project, and just so you get practice at doing it, and then you'll get practice more when you do your actual project. So let me just introduce you to the next topic. So that one was, let's see, Tuesday, Thursday, 2017. Okay. The next section is measures of position. So the measures of position is a simple calculation using the values that we have already calculated. So we're going to use the standard deviation and the mean and the actual data value. Those three things, when used in the appropriate formula, give you a measure of position. Meaning, the two questions are, am I greater than the mean or am I less than the mean? And if I am one or the other, how far away from the mean am I relative to the standard deviation of the sample? As I said earlier, if you're more than 3 standard deviations away from the mean, that's a very unlikely situation. So that this number, which is called a z-score, tells you, whether you're one way or the other by the sign, and if it's greater than 3, the value is greater than 3, then you're obviously something is amiss, or it's very unlikely to happen. So the measure of position is this z-score, and to calculate the z-score, all you have to do is take each data value. So if I have my list of 200 data points, they're going to be 200 z-scores, with a z-score associated with each data value. Half of them are going to be z-scores that are negative, and half will have a z-score that's positive. Most of them will be within plus or minus 1 as far as the z-score is. So it's just, all you do is you take the data value for the particular data point, you subtract the mean, and you divide by the standard deviation. So it's basically saying how many standard deviations am I greater than or less than the mean. Again, and there is a function in Excel that will calculate the z-score. It's a very simple calculation, so you don't really save a whole lot of time if you use the standard function. We'll do it manually, but it's something that, what we'll do is we'll quit there, and we can look at all this again, hopefully on Thursday if I can find a computer lab that's available during this time period. If not, if you have a laptop, you might bring it with you, and it would be more effective for you to do it yourself. I could look at getting a laptop cart. Anyway, just check your email. I'll let you know what I work out as far as Thursday is concerned. Okay, so that's it for today. Like I said, I will have your test back by Thursday.